All right, so section 8, here we go. Inequalities this time instead of equal to's.
Yes, so what we have to do is we're concerned about where f of x will be greater than 0 or less than 0, which means that we need to find x values that make f of x positive or x values that make f of x negative.
And remember, when we talk about f of x, we're actually talking about that y-coordinate action.
Yes.
You know, where are we big or where are we little?
F of x and y are synonymous, and then we look at what x values has the graph above the x-axis,
right.
which ones
From where
have
to
it,
where are you above?
and which ones are below. And
From where to
so
where.
these say greater than and less than, but we could also end up with greater than or equal to, or less than or equal to, and we'll just explore all of that right now.
Sounds great.
At this moment.
Let's do it.
Example number 1, let f of x equal all of this. Determine the real number values of x that cause f of x to be 0, positive, and negative.
Hey, can we do one of those sign chart things?
I think a sign chart would be a fabulous idea.
I love sign charts.
Okay, so what we care about with sign charts is where each part of this equals 0, right?
That is correct, yes, 100% correct.
So if at x plus 3 equals 0, that means that x equals...
-3.
Oh, awkward.
Wow, I got one right.
No, that's not what was awkward.
Oh.
Oh, x equals -3. I forgot the equal sign. Okay,
Oh, that was
x squared
awkward.
plus 1 equals 0.
But it doesn't.
Right, because if you start to try to solve this, you subtract 1 over, you square root. Oh no, imaginary. We don't want
we don't need
the
those.
imaginary ones.
Imaginaries
So
are taking a breather.
This is not going to cause us to put anything in our sign chart. X minus 4, set that equal to 0, and you get x equals +4. So in our sign chart, which we're going to show you here in a second what a sign chart is, these are the two numbers that are important.
Those are the ones.
So how do you do a sign chart?
So here's how I do a sign chart. Usually what I do is once I've got my factors like we've got right here, x plus 3, x squared plus 1, x minus, I just line those up on the left-hand side. Yep.
Okay, so x plus 3.
Yep, there's 1, and then right underneath that,
x squared plus 1.
Yep. And then
x minus
you know,
4.
x minus 4. And I've done it where I've done x minus 4, or x minus 4 squared.
Okay, let's
But
do squared.
Squared is usually easier. And then I make like a little line on the bottom, like on the bottom there. Yeah, little line. Keep going. All right, excellent. Yep. And then I draw like a vertical line for all of my zeros. Yes.
Okay, so that's -3.
Yes.
And yeah, because we set those things equal to 0, those were in fact zeros. That is kind of important.
Yeah. So there we go. So there's how my line chart, you know, sets itself up. And then I just like to pick numbers from the number line, and I don't care what the number is. I care about the SIGN of the number.
The sign.
The SIGN.
Why are you spelling it out?
Because it's a sign.
Okay. So what we do is we pick a number that's in between -3 and 4.
And a number that's less than 3.
And a number that's less than
And
-3.
a number greater than 4.
Right. If you have this situation, a 0 would be probably easiest to plug in.
Oh man, every time.
And then otherwise, it doesn't really matter what you pick.
That
but
is
the
correct.
smaller the better, usually.
Usually the closer to those zeros, the easier it is. And again, we're just interested in sign, not exact numbers. So
if I plug in a -4 or something bigger than -4 right here and for x plus 3, I get something
a negative. Yes.
If I plug in 0 here, 0 plus 3, I get a positive. If I plug in 5, I get a positive.
Yes. And so we're going to do this on each level of our chart.
So now I plug in -4 here. And if you think about it at the beginning, anything I plug into x squared is going to become positive and then add 1. So all of these should be positive.
They'll all be positive. And when you punch, if you're going to double check and punch this into your calculator, for heaven's sake, please put a parenthesis, -4, close parenthesis, square it, or you'll get the wrong thing.
Yeah. And then here, this is kind of a similar thing, right? If I plug in the -4 or the 0 or the 5, no matter what I get here, I'm going to square it.
That's correct.
So all of these should be positive as well.
And plus and plus. Now, here's what's really happening. What we're doing is we're saying, hey, we've got a number that's negative, and if we looked in this very first column here, we've got a number that's negative times a number that's positive times a number that's positive.
What's that going to give us?
That's going to give us a negative number.
Right. I might want to extend this line down a little.
And then if you look in the middle part where you've got, you know, all those pluses, that's a positive number times a positive number times a positive number.
And then positive,
and then the same thing on here. So if we want to know where these numbers are 0, positive, and negative, we just found that out because we're not interested in the exact value.
No,
we're interested in the sign.
Yes. So at -3 it's 0, at 4 it's 0 because we found the zeros up here. So if we're listing out where all it's 0, there's two places that happens at x equals -3 and 4.
Right.
And that's the only place it equals 0. If we are looking for positive, that's where our positives are.
And this is a good place to practice your interval notation.
Right, because we're going from here at -3. Is 0 positive?
0 is not positive.
It's not
0
positive
is
or
0.
negative. So from -3 until this line where we have another 0, okay, that's one interval that's positive. And then from 4, we would go on to infinity.
Right.
Because there's nothing that stops it over here.
That is correct.
So that's our positive interval.
Not even that little ticky mark you just put can stop it.
On accident. And then negative.
That's all the places where you get the negative sign on the bottom. And let me just tell you how important a sign chart is.
Over here.
You're going to use it all the time in calculus.
Yeah. It's like...
It's around. This is something to try to understand.
Yeah, so we just said, okay, it's negative over here from negative infinity until we got to this number, which was -3. And then we said, oh, it's positive from -3 to 4. It's positive from 4 to infinity. We could check this on a calculator pretty easily by sticking the original function in. And what should happen here is, this is what, a 5th degree polynomial.
5th degree.
And it's bouncing at 4 because of that squared, which is why we end up with it being 0 at 4, but it not switching from positive to negative. Because we've got like a...
We've got a whole bounce situation.
Yeah, we've got like this kind of situation-ish going on, something like that.
Right.
And so you can tell, okay, well, that's where it's 0, that's where it's 0, and then it's positive up here, negative down here.
Perfect.
Yeah. Hey,
all right.
Precalculus 2.8 notes, example 2. Solve 2, blah, 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 blah. Analytically. What does analytically mean?
Analytically, I think that means you drive to the... You don't use your graphing calculator.
Not graphically is what we're talking about when we do something analytically. So if we're not doing this analytically, I don't think that this is factorable.
Factor by grouping.
We can't factor by grouping.
Factor by slide dividing.
We cannot factor. We can't factor.
Rational zeros.
Rational zeros theorem. Okay, so remember we use these two numbers. We're saying the factors of 24.
Which there are several. Keep going, 3, keep going. Yep, keep going. Yep, 6, yeah, then 8, yeah, then 12, and then finally 24. There's those guys.
Over.
Oof. I'm getting a hand. My hand's hurting right now.
You're not doing anything. Plus, over, plus or minus 1, plus or minus 2. Now, fortunately, you'll have all of these numbers on top over 1, all of these numbers on top over 2. So you're really just going to have these top numbers and a few fractions like...
And not even very many
plus
fractions.
or minus 1/2.
Right.
Plus or minus 3/2.
Right.
And that's actually
and that's it.
All
Everything
the rest of
else
them will cancel into things that are already on the top here.
That is correct.
So what the best case scenario is, we pick something and hope that we can maybe see a lower or upper bound.
Right.
So how about we pick something kind of in the middle-ish?
That's a great plan.
So I'm going to pick 6 and do synthetic division.
So we're going to check 6 and see if it works. And basically, if we don't get a 0, we know we can't use 6. But we also can tell when we get done with synthetic division
if it is or is not.
If it is or is not an upper bound. And
or maybe lower bound.
Or maybe a lower bound.
So
it can't be a lower bound. It's not negative. Got to have less than 0. But we can tell if it's an upper bound. And I'm thinking upper bound. So there are no zeros
that are bigger than 6.
Bigger than 6. That means we can eliminate 8, 12, and 24.
Hey, that's awesome. Now let's try
fantabulous maybe.
4. You want to try 4?
Okay, yeah, squeeze in one time. We'll try 4 and see what we get.
And if we don't get it here, I mean, that's
then we squeeze in again because we should get a bound.
Going.
So bring down the old 2. Multiply and add, people. Multiply and add.
Just kidding. Sorry. Just kidding.
I
feel
a
like 10.
I feel like that should be a -6er.
Yeah, it should.
And pick your pencil.
Yep.
There we go. All right. Yep.
Okay. Woohoo.
High five.
Yeah. Woo! Okay. So
we
knew that 6 was an upper bound because all of these were positive. So we tried something lower, like 4. Also, you could have eliminated 1 as a possibility pretty easily here by just plugging in a 1 and seeing, okay, is that going to equal 0?
Right, and it doesn't.
Yeah. So now we have 2x squared plus x minus 6.
We can now factor a lot of different ways, either by
Slide and
factoring,
divide, or
slide and divide,
box.
box, quadratic formula.
Right.
You take your pick. You do what you feel necessary.
So
Looks like Miss Stevenson's going with the old attacking slide and divide style.
So what multiplies to get negative 12? That will basically end up subtracting to get us 1, and then divide by what we slid by. And so at this point, like whenever you work this out, we would get what? X plus 2.
X plus 2, x minus 3 halves.
Yeah, we could leave it as x minus 3 halves, or we could write it as 2x minus 3.
But 3 halves is technically what
That's
we need.
the 0,
so
right.
that is what our 0
Right,
is.
so we had, don't ever forget about this one over here we found. We had 4, negative 2, and positive 3 halves as our zeros. 4, negative 2, positive 3 halves.
So
Now
what we're going
make a
to
sign
do
chart.
is make our sign chart, and what you want is you actually want the linear factor to make your sign chart. So we would kind of need everything that this factored down to.
X minus 4,
Yep,
because it's a 0 at 4.
Right, x plus 2 because it's going to be a 0 at negative 2, and x minus 3 halves. Now, I know some of you are getting sweaty seeing the fraction there.
It'll be all right.
It's all good. We don't need an exact number. We just need a positive or negative value. Like, what is this? Wow, what happened on that? It was had a wiggle in its jiggle. So go ahead and list your zeros from
most
smallest
negative
to most negative to most not negative.
or positive.
Excellent idea.
Oh, that's not, no.
For negative 2.
Negative 2.
3
Positive
halves.
3 halves.
Positive 4.
Positive 4.
Fabulous.
Okay.
Okay.
So then let's pick numbers to plug in. So like
Negative 3.
Negative 3. Here we could have a 0.
Yeah.
Here we could have, we have to have 2 or 3,
Right.
so 2 would work, and then 5.
And where we've got negative 3, 0, 2, and 5, you could pick any number. It just needs to be in that interval.
Yeah, be careful with the fractions.
Yeah.
So make sure you actually pick something between the
Yes,
the
pay
fraction
attention.
and the other number.
Pay attention.
If I plug in negative 3, that's a negative.
Negative number.
Negative 3, that's a negative.
Negative number.
Negative 3, oh, that's
Negative.
a negative.
Yep.
So then 0, that's
It's
a
going to be negative there. Positive.
Positive.
And a negative.
Negative. I didn't put these in order.
That's okay,
That's
though.
okay, though.
That's okay.
Yeah. Then 2, that's negative, positive. 2 minus 3 halves. 3 halves is 1.5, so 2 minus 1.5 is positive. 5 would give us positive, positive, positive.
All right, and then think about it this way. Negative times a negative
Times the negative.
times a negative.
Would give us overall a negative.
Yep.
Negative times a positive times a negative. Gives
Negative.
us a positive.
Yes, that's what I said. A negative positive, which is always a false positive negative, which is positive.
Negative, positive, positive is
Negative.
positive, positive,
And
positive.
then super plussies.
What it asks us for is greater than 0, which means that it's not equal to at 0. We're looking for the strictly positive entries.
Positive only.
So that's this right here and this right here. So let's write that in interval notation. This first interval where it's positive is negative 2 to 3 halves.
Yep. Together with
4 to infinity. Whew.
Man, my hand. Okay, enough of that analytically business.
Let's do it graphically this
Just
time.
rock on.
So that means that we need to solve graphically. So first off, let's look at how do I put this into the graphing calculator, because that's what it means by graphically. We would need to move everything to one side of our equation and then plug it into y equals. So what you should actually have in there is x cubed minus 6x squared, but add over the 8x, so that's plus 8x. Subtract over the 2, and then it's less than or equal to 0. So we put in y equals this.
Got it. That's what I got the graph that we're showing there.
And what we want is less than or equal to 0. So we want all of the places where our graph is below the x-axis or touching the x-axis.
So we could also use our graph then to so I'm on it right now.
So these are quotation marks to say write this again right here. Or it could be a smiley face. depending on what you want it to have. You should end up with a graph that looks like this, but as I just whispered to Mr. Hazelwood, it looks to me like we're going to actually have to calculate these zeros the old-fashioned way on our calculator. Remember that for the TI-84, you go to second trace, and then zeros is an option, or on the TI Inspire,
menu analyze.
Menu analyze. Either way, you should be able to come up with some zeros. Are you ready to go with the zeros?
Ready, rock on.
All right, so
zero number 1 is right. Here we go. Little lag. There's a little lag here, but that's okay.
That's just kind of the day we're having.
0.325.
0.325. Hey, 3 decimal places, always a great number of decimal places
Great
to
number.
go to. None of this whole number business.
None of that.
No significant digits. We don't do that in
No,
this class.
this is not science.
We're the mathematicians.
We are.
We hand the scientists the information, and then they round to their heart's content.
They can round all they want to.
What's the next one?
Working on it.
Okay.
What is that? What is that stuff where you're like a fake chemist? You know, like fake.
Pseudochemist?
No, you know where you
meth dealer?
created like fake gold.
Oh, an alchemist.
Alchemist. Yeah, this isn't alchemy. I don't know. It's really taking its time here. Okay, it's like processing all the way to the Indian Ocean and back. Wow, there's a lot going on here. Hold on one second. So, without using witchcraft, 1.461. 1.461. 3 decimal places.
Okay, how about this last one that looks close to 4?
Looks really close to 4, and analyze. I almost hate to do it, but here we go. Witchcraft.
Keep going. You can do it, calculator.
So, 2 guys walked into a bar. The 3rd guy ducked.
You've told that one before.
Oh, shoot.
No one was probably listening, so.
So there
Hey,
you go.
knock,
Here we
knock.
go. Here we go. Who's there?
Noah.
Noah who?
Know a good knock knock joke? I may have done that one before too.
That's
Have
a
I
good
done that one?
I don't know. Okay, here we go. Finally, 4.214. Yuck.
Okay, those are our 3 zeros here. And then we want less than or equal to 0 here. So we want the negative values and the 0 values.
So we can actually include the zeros for the first time on this set of notes. Whoops.
So it's below the x-axis. It's negative here from negative infinity until we get to our first 0, which is
0.325.
Right. But we are including 0 because it can be equal to, so we put a bracket.
That's excellent. That's an excellent decision.
From 0.325 to 1.461, it's positive. From 1.461 until we get to our next 0, it's negative. And again, bracket those things because it's equal to.
Please do.
And then from 4.214 on, it's positive again. So that's our answer for this. And that's how you do it graphically.
Yeah. All right. We're going to look at some more graphs here and determine where the graphs are greater than or equal to 0, whatever.
Whatever's asking
More fun stuff.
Investigate the graph of x squared plus 7 times 2x squared plus 1 and determine where the graph is greater than 0, greater than or equal to 0, less than 0, less than or equal to 0.
It doesn't say analytically or graphically though, but there's a picture right there.
Yeah, so we could get this by putting this into our calculator, and if you look, this looks greater than 0 to me.
I'm pretty sure
the whole time.
there's no less than 0 there. I mean, the little red line never crosses the x-axis.
So would we do greater than 0, and we would say like negative infinity to positive infinity?
I mean, you said that like it's a question. It's more of a statement. That
Oh,
one.
okay. And then greater than or equal to 0.
Same place, actually, because
it's still greater than or equal to 0 at all those places. Even though it's never equal to, that's fine. It's still greater than or equal to.
It satisfies one of those 2 conditions.
Less than 0.
Empty set on that, or however you want to say it.
None.
Not possible. Not none.
Or the empty set you do with the 0 with the line through it.
Yeah.
Less than or equal to 0.
Yeah, same thing.
Same thing.
All right.
That was a fun one. Okay,
Pretty much
now
empty.
how about this one? X squared minus 3x plus 3 times 2x plus 5 squared. Where is the graph greater than 0?
I sense some factoring in our future.
Really?
Yeah, because don't we want to figure out exactly where that crosses the x-axis there? Because
it should cross at -5/2. But that's not what that is.
I mean,
no, that is. That's a -2 and a -3.
-2 and a half.
This 0 is this 0 right here.
Where it's bouncing.
2x plus 5 equals 0. That's -5/2. This other one doesn't actually factor because look, it just comes down and at some imaginary point apparently bounces.
Totally
if that's
imaginary.
even a real thing.
Yeah, I don't even know what you just said.
-5/2. Okay, so where it's greater than 0 is, well, from -infinity until we get to -5/2.
But you can't include -5/2 because
it's 0.
It's actually a 0 there, and we don't want the 0 on this.
Not on this one. -5/2 to +infinity. But greater than or equal to 0 would be the whole shebang.
Whoa.
From
Why is that?
-infinity to infinity, because now we can include that missing point that we had. So if we fill in this hole right here in our interval notation, that's -infinity to +infinity.
Right. Now, what if I wrote it from -infinity to 5/2 with a bracket, and then from 5/2 with a bracket to +infinity?
Technically, I guess that would be right, but that'd be silly.
I agree. Okay.
Less than 0.
Nah.
Nothing is less than 0 because we have this 0 here, but nothing is underneath our x-axis. So none, or you could say the empty set, and then less than or equal to 0.
5/2, -5/2.
Only -5/2. So that'd be like a x equals -5/2 kind of situation. That's the only value that's less than or equal to 0 because that's the only value that's equal to 0.
Yes. Wow, that one looks irrational there. Or rational. That one looks rational. That's a rational expression. Yes.
And so we're going to treat this similarly to our other polynomials we've had by making a sign chart.
There's no need to make it harder than it is.
No, and we still are going to look at basically the factors because 2x plus 1 on top here tells us our x-intercepts where that equals 0.
Right.
Right, and those are important values. So that would be -1/2.
And then on the bottom, those also tell you your important 0 values because they're asymptotes.
Right. And so there's a difference here. These on top we're getting x-intercepts or zeros, and on the bottom we're getting vertical asymptotes. But either way, that's telling us a change from positive to negative, or a possible change.
Right, a possible change. Now, you might not get a change here, but
yeah, you might not, but you might. And that's why we have to make the sign chart to check. So we list out all of our factors from the top and the bottom. And if this hadn't been factored out, that would be our first job, would be to factor out.
First order of business.
Okay, so we've got 3 things here.
So we're going to have zeros, and you want to put these in order. It just makes it a lot easier on yourself. So -3, -1/2, and 1.
Okay, and then we pick numbers that are on either side of each of these. So
right.
like
you can pick whatever number you want.
-1.
0.
0 would be great, and then 2. And then you just go down and say, if I plug -4 into these, am I getting positives or negatives? So
you get negatives on all those.
Negative, negative, negative. At -1. That would be a negative.
Be a negative there, and then
a positive. What happens if you plug it in and get?
Something's wrong. Negative, but that should be a -1. That should be -1. X -1.
Oh, okay. Whew. I just got a little worried there. Okay,
I did
so
too,
x
because the math
-1.
wasn't going to work out.
No, not so well. X -1, when I put in a negative, that's a negative.
Yes.
When I plug in 0, that's a positive,
plus,
a positive,
and
negative.
minus, yep.
0 is easy. When I plug in a 2, positive,
them are all pluses. All right, so now go through and do the whole, if this times this times this, what sign would you get?
Negative times a negative times a negative.
It's negative.
Negative times a positive times a negative.
It's positive.
Positive times negative times negative.
Negative.
Positive.
I'm positive.
Positive is positive. So, by the way, in case you didn't know, an odd number of negatives makes it negative, and an even number of negatives makes it positive.
Right.
Right. So these two had even numbers of negatives. So that's why they were positive there.
Okay. I like the way you talk.
Okay. So we are trying to find here A, B, C, and D. A, where is our graph 0?
Which is different than undefined, which Mrs. Stevenson was just talking about a second ago.
Yeah, where x is 0, where our x-intercepts are, where we get our zeros from.
Where do we cross the x-axis?
Yes, that's -1/2.
Righto.
Okay, and then B, where is it undefined? Well, that's where our vertical asymptotes will be.
-3 and 1.
And then C, where is it positive? Well, it's actually positive in a lot of places here, from negative 3 to
but
negative
we
1
can't
half.
quite include.
Negative 1 half to 1.
You can't
1 to
say
infinity.
negative 1 to infinity. You can't do that because positive only means
Positive only.
positive
Not
only,
0.
not 0, and definitely not something where we're undefined.
Yeah. So we
yes,
have
you're going to
3
have a lot to
intervals here.
write here, and suck it up and just, put on your big person britches and write it all out.
Right. Get out your fun pencil and never mind. D, negative.
I don't have a fun pencil.
You have one with like a skateboard on it, don't you? From the math closet?
You're right, I do. Okay,
Negative infinity to negative 3.
And that's where we
That's
are.
where negative. And that's what we wanted to do. It told us to use a sign chart, so we did. So we're good.
No, that's good.
Solve the inequality. So
Are you serious right now?
This parentheses right here underneath this radical, we don't really need that one right there, like that I started to erase, but I don't think I can squeeze my little pencil deal. Oh, look, we don't need it.
Wow.
Okay, so solve the inequality. This is still technically like kind of factored into x minus 3 and then the square root of x plus 1. So we're going to make a nice little sign chart here.
And we're going to use the two pieces, x plus 1 and x minus 3. Now, pay attention to the square root of x plus 1 because there's certain things we just can't put in there.
That's right. So let's go ahead and talk about our zeros because we
Let's do.
kind of skipped that. I skipped that on accident. X equals 3
Right.
would be our 0 here.
Right. And
then
negative 1, x equals negative 1. Because that is where we get 0 in the denominator.
Underneath the square root.
Right,
yeah.
under the radical. Yes.
Yeah.
You speak it, I say it. So, but we have to keep in mind now that we are undefined for any values that are actually less than negative 1. So
yeah, because if I plug in negative 2 here, I get something crazy.
Yeah, crazy. Like it'd be cats and dogs living together
and that would
sheep
just not
laying
work
down
out.
with the lions. It'd be wacky.
So when I plug in negative 2 here, I get a negative, but when I plug in a negative 2
That's
here...
undefined. No. Okay, you can write that. Sorry.
Undefined.
I thought you were going to put like
a negative times undefined is undefined.
Undefined anywhere is undefined.
Yeah, so 0 if I plug in,
it's like the nothing from the never-ending story. There's nothing.
Right. 0 I plug in and get negative. 0 I plug in and I get positive. And negative times positive, negative.
Yep.
4 I plug in and both of them are positive.
Right.
And
again, we don't. Who cares what the square root of 5 is,
or
whatever?
I don't care what it is.
Doesn't matter.
But all that matters is that it's positive.
Yeah.
In fact, anything we plug in here will either be undefined or positive.
That is correct. You are 100% correct, as always.
We wanted greater than or equal to 0, which means positive and 0.
Right.
So at negative 1, we were 0.
Right. So we do have a 0 there, even though it's only one number, and that's okay.
And also,
and from 3 included.
Yes, because it's equal to, we include 3.
All the way up to infinity.
Are we okay with this notation here? Negative 1.
I'm pretty much okay with that notation.
And 3 to infinity?
Yes.
Okay, there we go.
All right.
Solve the inequality.
Another one. So guess what? It's already broken up, and it's actually not as horrible as it looks.
Right, absolute values. Oh no, that's terrible. But wait.
Everything's positive.
With absolute value.
Yeah.
Right. So what happens here is x minus 2 equals 0 on top.
So our 0 would be a 2.
Yeah. But also where the bottom here equals 0, what's inside the absolute value, that's going to be important.
So negative 3.
Yeah. And so that's still on the bottom of vertical asymptote. And what we're doing is because we're saying that x plus 3 in the absolute values equals 0. Well, normally we have to account for like a positive and negative case when we have absolute value, but 0 is not positive or negative.
You're darn tootin' it's not.
That's why it's so easy to solve. So sign chart. Absolute value probably, right? Should I stick the absolute value here?
I think that's my right shoulder.
That was your right shoulder. You're absolutely right.
My writing shoulder.
You're right.
I can't write anymore on this one. Yeah, sign chart. Man, I'm gonna have to go on the IR. So what we're gonna do is we're gonna pick in order negative 3 and 2 to be our zeros.
So then you pick numbers on either side, just like what we've been doing.
Yep, it's no different.
So if I plug in negative 4 here, I get a negative.
Right.
Here, though, I get a negative, but then it makes it positive.
Absolute value, everything that comes out is going to be positive.
In fact, we could go ahead
and
all
those.
Well, bam, all of those are positive.
Righto.
So then 0 you plug in, and you get negative.
Yep.
Do you want to tell them to come in? You apparently have
Sun chips or hot Cheetos?
Sun chips are fine. Thanks, you're the best.
And then a negative times a positive is a negative. Negative times positive is a negative. Positive times positive is a positive.
And hey, looky there. So we're all done except for now we have to figure out where we're less than or equal to 0.
Right, so we're definitely less than in these two intervals, and we're equal to here at 2. The question is, are we actually equal to at -3?
You know, we're not, because we're undefined at that point. And that's
Because it's the bottom of the fraction.
Yeah, you're on the bottom. And so you've got to really pay attention to that, or that'll be an oops that you'll make. So,
yeah. So we go from -infinity
to -3.
to -3, but we don't include -3.
No, it can't include -3.
And then we go from -3 to 2, but we do include 2 because 2 is 0.
That is correct.
There you have it.